Okay, so I just start my micro. Every one of you can start your micro. I just give another 10 seconds to start the micro session. Has everyone started? Shall I start? The follow through. The follow through is like as we did last time. I do one step and give you 10-15 seconds to complete that step, and together we proceed. Is everyone ready? Ding dong. Everyone ready with the?
Yes, sir.
Yeah, that's ready. Great. Okay. So the first step, go to compile menu. Do as I say, go to compile menu. Click on compile one logic gate. The first option, compile. First option, compile one logic gate. Once you have opened it, okay, it should look like this. Drop down, select and some statement written, the second statement, I think yes. And is equal to A and B. Have you selected it?
Yes, sir.
Okay, just click on compile. It should produce something like this. This is what, you know, this is ready-made chaat masala board. What do you call it? Ready-made dishes. You have to just boil up and eat. Something which is readily available to eat. Okay, so this is your AND gate, okay, and this can be used to make any of your design ahead. Okay, so we will test this design that is this working as an AND gate or not. Okay, so the first thing, just go close to your nodes A and node A. You must be able to see something like written on the red line, red block, polysilicon A. So double click on A. It should open this kind of window. Is it?
Yes, sir.
Double click on the node A where the text exactly is written. You can double click on that A text. Did you find this window? Double left click. Can I have a couple of yes or no?
Yes, sir.
Everyone ready? Okay. Now in this window, just go on the clock tab. Go to clock tab. Okay, clock tab. Gone?
Yes, sir.
Time low as 1 and time high as 1. Just modify time low as 1 and time high as 1. Modify time low as 1 and time high as 1.
Yes.
Okay. Next step is click on not in simulation. This bottom one button. So it will show now visible in simulation. Okay. Is this okay? Everyone has done this. You have to change the time low as 1, time high as 1, and click on this button. So it should show visible in simulation. Okay. Yes, Kalyan. What went wrong? Anyone who I will just move as timed step. Okay. So if someone falls behind, so don't worry. Just keep your hands off from the mouse and start watching. Don't try to run and try to pick up the pace, because I will be sharing these design files with you, so you can later words find it and you will get the video recording. because if you stop and try to solve the problem on your own, you might land up at different place, and then you will not understand anything. So it's better if you are lagged behind, so start from there. I mean, start watching from there and try to remember. That's it. So just now click on assign. So what has happened that we have applied a square wave clock to the node A of the AND gate. Okay, no problem. Now the next, it is the turn of the B. So double click on the B text. Do the same step. Double click on this B text, this B one. Okay, so it should open again. So don't proceed until as I don't ask you to do the next step. Don't try to assume that sir is going to apply clock also on this, so I will do first. No, there is no race. So don't proceed further, please. Okay. Now instead of clock, go to DC supply. Okay, instead of
Yes.
clock, go to DC supply. Okay.
Yes, sir.
Instead of clock, and then just click assign. Do nothing else. Not visible in simulation. No, nothing. Okay, just assign and come outside. Okay. So
Yes,
what
sir.
we have done is in this AND gate, we have applied a square clock at the one input, and the other input we have applied an VD supply. So what is going to happen? It is going to work as an inverter. Okay. Now double click on the AND. You see an AND text on the top right corner. Okay. So just open it and click not in simulation. That's it. Only click make this as visible in simulation, because we want to see the output the AND gate. This is the output the AND gate, and we want to see in the simulation that what is coming on this point. Just click assign ahead. That's it. Okay. So now I just change color, but for you guys, no need to change color. In my case, what is happening, because my screen is also getting recorded, so it is running.
Sir, after going AND gate, what should
Sorry.
after going near a AND gate, what should we do?
Did you applied and double click on the AND node? Double click on that AND. Just click this tab. I mean this button, visible in simulation, so that this is the output of the AND gate, and that should be visible in simulation. So just click on that and assign. That's it. Now run simulation. This play button. You see a play button on the top side of the taskbar. It must say run simulation. A green color play button is there. I think you should be familiar by now. When you open this, I don't see any output, but then I have to change the time scale to 5 nanosecond. So yes, I see an AND gate. So it works as a follow through. For 0, I have a 0. For 1, as a 1. So it's just like a buffer design, right? So it just acts as a buffer. Are you getting this simulation run? No. Okay.
No, sir.
No problem. What do you see in Swati over there? Okay. Those who have got it, just hold on for a few moments till I get the rest of the first waveform which came. Okay. Did you double click on the AND gate and said that it is visible in simulation or not? Because if anyone sees only one waveform, okay, so that means you have forgot to click that visible in simulation button for the second one. If you are not able to see two waveforms, so that means you forgot to click that button. Okay. So in that case, you have to double click on that node which is not coming. If you're not getting AND output, double click on AND and say visible in simulation. If you're not able to see A input, so double click on A and click visible in simulation. Okay. So you should see something like this simulation waveform. Okay. So this is a simple AND gate, but it's working as a buffer. It's not working as an AND gate as of now, because we have tied the B input to the VCC. Okay. So this guy is working as a simple pass gate. Okay. So now what do we do with this?
Sir, I'm not getting the waveforms, square waveforms, sir.
What you're getting?
Sir, I'm just getting this half sine wave and then a straight line, sir.
Okay, so on the right hand side, you see a time scale.
Yes, sir.
You just drop down and select as 10 or 5.
Okay, sir.
Now reset.
Yes, sir. I got it, sir.
Okay. Okay. So because your simulation runtime was, I mean, pulse width is 1 nanosecond, your runtime was less than 1 nanosecond. That's why you were not able to see it. Okay. Okay. So everyone is comfortable in making this AND gate, right?
Yes, sir.
Okay. Now let's make this something more interesting. So you can save this file. Go to File, Save As, and anywhere you say that any name you can give. Just save this file. Can you, all of you, just save this file quickly and clear this file. Just click New. And those who were not able to follow it, maybe this time we can do it again. No problem. Ouch. This would become complicated now. The ring oscillator. Has everyone done it?
Yes, sir.
Shall I start? Okay. So then please do this, and I will little bit go in a faster mode because this experiment can become bigger. So I don't want you to fall behind. Okay. So just keep your eyes and attention so that we follow the 10-second or 15 seconds clock. Okay. So first thing, go to compile. Compile one logic gate. Select AND A and B. That is, we have to make an AND gate. Click compile. I assume everyone must have made this. Go to compile, compile one logic gate and AND gate. Before that, clear everything, make a new file and start again. Okay. I believe everyone must have done this, right?
Yes, sir.
Okay, so it should not take too much of time, right? So just click zoom out so that you get some space and bigger area on your drawing board. Okay, something bigger area like this. Just make zoom out, click minus button so that your AND gate becomes smaller and you get some little more area on the right hand side of the page. Is this okay? Have you adjusted this?
Yes, sir.
Okay. Now from the palette, click Cmos Vlsi. Click Cmos Vlsi. And whatever the default values of N and P are there, let it be like this. Don't touch them. We will not touch, modify them. So just select one NMOS, generate device, and somewhere in the center over here, you know, close to AND gate, but a good space should be there with the AND gate. Place it. Is it done?
Sir, could you please repeat it again?
Just click on MOS generator and select NMOS and generate device. That's it. Whatever the default values, don't touch the default values. So generate an NMOS and place just next to the AND gate, just like the way I've done. Is it done?
Yes, sir.
Yes, sir.
Okay. Now
Yes, sir.
again click MOS generator. Do it again, MOS generator. This time select a PMOS. This time select a PMOS and generate device. And just bring it on top of the NMOS and place it. On top of the NMOS, just place the PMOS, aligning both the gates and the metal lines, aligning nicely. Now, if I zoom the area, this is how it should look like, the inverter, NMOS, PMOS. Is this looking good, everyone?
Yes, sir.
Okay. Now, take the tin gate from the palette, the red color block tin gate, mentioning tin gate, left click on it. Only left click once. It will be selected automatically. Then short the gate inputs. Do you see like this? The short the gate input like this. Just left click from the start point of PMOS gate and end it at the NMOS side. Even they overlap, that's okay, no problem in that. Overlapping is all allowed. Is it done?
Yes, sir.
Okay. Now, somewhere on the center side of the inverter, left click and draw a red block like this on the left hand side. Don't go too far and don't, I mean, at least your anvil which is there, is it thoda, I mean, a little bit outside than the anvil, little bit outside. Not too far, not too short. Is it done?
Yes, sir.
Okay. Now select the metal one. Left click on the metal one layer from the palette. Left click on the metal one palette. Okay. Then draw a block shorting these two nodes of the PMOS and NMOS. Okay, these two nodes should be shorted like this. And once they are short, from the center side, extend and make a metal line like this. And remember, they should be same body. Huh? It should not be like this, that there is a gap or spacing in between. The metal lines are shorted. These ones. Is this clearly now visible? Has everyone done it?
Yes, sir.
Okay, great. Now zoom out a little bit so that you can comfortably approach the entire design. Okay. Now go to edit. Click on duplicate XY. Click on duplicate XY. Then draw a box around the inverter. Draw a box like this, covering the entire inverter. Don't select anything else. Don't select the AND gate parts and components. Only the inverter side. Okay. So it should make them in yellow, and it will ask you that how much you want in X direction. So I say X in direction 3, and in Y it should be 1. Can you see this setting?
Yes, sir.
Just make multiply in X as 3 and in Y as 1, and just
Excuse me, sir.
generate.
Sir, how to cancel something, sir? Which is drawn on the screen.
I think you have to delete that part. You have to take this gun, you see a cut, delete some layout, and select that part of it. For example, if I have to delete my existing one, I select this delete and draw a box, the area which I want to delete. So these two parts would be deleted from my design. So that is deleted now. Okay. Then I redo it. I go to edit, duplicate. Those guys who have done it, no need to do that. Duplicate XY. Then I select the area which I want to duplicate. Say multiply in X as 3 and multiply in Y as 1 and generate. Okay, so this is how it makes 3 inverters in adjacent to each other. Rest everyone, shall I proceed?
Yes, sir.
Okay, now take the metal one line, again click on left click on metal 1, and from the rightmost side of the NMOS, the bottom side of the terminal, the drain, draw a block like this. So it will short the NMOS, all NMOS on the bottom side. Okay.
Yes,
And
sir.
same thing you have to do on the PMOS. Remember that you don't short the other side of the leg, huh? Otherwise it will make something else. Something like this. So all the upper terminals of the PMOS are shorted, the drain part. Okay. Is it done?
Yes, sir.
Okay. Now you see these nodes, these points which are almost touching to each other. So come on the center part of it, bring your mouse exactly on the center part, right click and say connect layers. So it should show a pink block like this. Then do for the second one. Exactly on the center, bring your mouse exactly on this, the point at which they are joining each other. And right click and say connect layers. So it should do something like this. Are you able to do that? Is it happening at your place?
Yes, sir.
Great. Happy to hear this. Then select the metal one again. Select metal one again. Then this is your output node. This is your output node. So you can take it a little bit above of the first layer, a block like this. A block like this going upward, shorting the output node. Then take it to the left, again left click and draw a block, and try to make all the metal lines of the same thickness. Then bring it down, almost overlapping the gate input of the input side. Are you able to see this?
Yes, sir.
Then these two nodes which are overlapping each other, right click over here and say connect layers. So it will short the output node coming back to the first input. Is it done?
Yes, sir.
Okay. Thank you. So now we short the anvils. You see these anvils? We short them. So for shorting them, the best is that, okay, maybe you can just select the anvil from the palette. From the palette, you see somewhere on the one of the second last layer is anvil. So left click on the anvil and just draw a block which are the missing space between the anvils of these layers. If there is something overlapping, that is also allowed. Huh? I mean, you can do something overlap like this also. So short these missing spaces. So all these three anvils of the inverters should be common so that we can apply a single bias to all of them. Otherwise, we have to apply three biases. Okay. Done?
Yes, sir.
Okay. Now let's do the biasing. Or you want to do the connection first? Or let's do the biasing first. So you take the VDD supply from the palette. Take the first VDD supply, not the second one. The first VDD supply from the palette. Over here, just below the MOS generator. And left click on the anvil. So your anvil is now reverse biased. Okay. Next, take VDD supply again. And this time connect to the PMOS upper terminal, this common path. Don't drop it on the topmost. Huh? This is your common PMOS drain, and this has to be biased to VDD. Is it done?
Yes.
Now take the ground. Take the ground. Left click on the ground, and then left click on the NMOS bottom terminal, which is common to all three of them, so that this is biased to VSS, and it will become the ground of it. Now take the visible node, take the visible node and take the visible node and click on this node which is supposed to be output. We can call it as S1 is okay, no problem. I have no problem with S1. Okay. If you're getting S1, that's okay. Or S2 is also okay. S3 is also okay. S13 is not okay because that is an unlucky number. So you won't get outputs. So don't put S13. So assign it. That's it. Okay. So our oscillator is ready, at least. Now we have to connect with the AND gate. Okay. So I believe everyone remembers that what we are doing, right? Don't make yourself lost in. So you can click on zoom all so that you can see everything in one close up shot. Is this visible? Okay.
Yes, sir.
Yes, sir.
Okay. Okay. Now what you do? Just double click on A input. Double click on the A input of the AND gate. Sorry. Double click on the input of the AND gate. And make it as a clock. Time low as 1 and time high as 5 or 4. Just make time low as 1 and time high as 4.
Yes, sir.
And click visible in simulation. Click visible in simulation. Assign it. That's it. Has everyone done this?
Yes, sir.
Yes, sir.
Okay. Now take this delete button. Do you see this delete button?
Yes, sir.
Click on this and delete this part. I mean, I'm sorry, but I was mistaken. Delete this node. It should not completely deleted. Only this part is delete. And delete is very careful to be used because if you click double or something like this, it may go wrong. Delete this connection. Because you remember that we have to make something which is like this is our inverter, right? And we have to short the feedback to the gate input, isn't it? And this is our A, and this is our output. Sorry, S1, right? So this is something what we are making. So we come back to micro:vent. So I delete this node. Has everyone done this?
Yes, sir.
Okay, great. So just carefully, you have to short this node to the B input of the AND gate. Okay. So what do? You just go to palette, select the metal one, and maybe just in my case, it is not aligning directly. So I just take it a little bit above and left click, take it till almost to the B side and short on the top side of the B. You see this one? You have to bring it on this node, only on this node, and no need to connect anything because already a wire is present over there. You have to just connect the metal one layer. Are you able to route this to a new location?
Yes, sir.
Yes, sir.
Okay, great. Now we connect the output of the AND gate to the input of the inverters. Okay, so for doing this, you take the metal one layer again and start from the AND output over here. Start from the AND output. I draw a block like this and bring it down, and somewhere over here I just take it and connect like this. Is this okay?
Yes, sir.
Now on this overlapping point of output of the inverter, output of the AND gate and the input of the inverter, I just right click and say connect layers. So what will happen? The output of the AND gate gets shorted to the input of the inverter. Is this ready?
Yes, sir.
Yes, sir.
Now I will verify that my system is well connected and there are no errors in my system connected. So what I do, I double click on the gate input of A, the red one, the red body of the AND gate A, I double click on it. So it should do something like this. It should highlight only A and it should de-highlight the entire rest of the circuit. Is it doing the same at your place?
Yes, sir.
Is it doing the same?
Yes, sir.
Okay. Now only left click once the B input. Only left click once on the B input. Is it doing something like this to your place?
Yes, sir.
Here you can see that the B input is a red line and the output goes to the B input and connects to the feedback of the last output of the inverter. So that makes me comfortable that yes, my connections are correct. Isn't it?
Yes. Yes.
Now left click once on the output of the inverter. Left click once on the output of this inverter node. Anywhere you can click on this node, anywhere. So if it is connected, it should show highlighted. Connected nodes are highlighted now. So you can see the output of the AND gate goes to the first stage inverter input, isn't it? So everyone is getting the same connection confirmations.
Yes, sir.
Okay, great then. So our system is ready for simulation. So I just changed the background color of mine. If you want to change yours, then it's okay. Otherwise, leave it as it is. Okay, you can just click on simulation. So you should see something like this. So here I wait for your comments that kiska chala, kiska nahi. I mean, who was able to simulate and who not. So are you getting this waveforms? If not, check your time scale. Check both A and B are in the simulation.
Yes, sir.
Yes, sir.
Most of you are getting it. There are only two girl voice I hear. What boys have left and ran
Yes,
away?
sir. Done, sir.
Okay. The rest of the boys, where are you? Okay.
Yes, sir.
Has everyone got it?
Yes, sir.
So that's your ring oscillator with a control. I mean, it is on for 4 nanosecond and off for 1 nanosecond, right?
Yes.
So just save these files always whenever you are drawing something, just save these files so that we can refer them later and talk or discuss about anything you want to. So I will also share my file with you guys so that in case anyone wants to um, talk on it, so you can come to me. That's great. So I just share these files with you guys. Okay. And then I just write the date to assignments. Anyone has any questions or discussion wants to make, then you're most welcome. So as it's a single day assignment, so I don't give you too much. So I'll just ask you to do the same ring oscillator at your home. And this is just to practice, because as you saw that there are no more number of steps involved. So it gives you better practice and understanding of the software features, that, okay, what to click, how copying is done, how deleting happens, how duplicating happens, all that stuff happens, right? So this is just to make you practice with the software features and functions. This is what I will do with the progress of the course. And my objective, but still, is not teaching you about the software. My objective is to teach the topic and the subject. I will not be much talking on the software, less and less about the software. Okay, so tomorrow just bring down these two experiments. I've just placed the assignments over here for you guys. Okay, I believe you can easily download and get these files. Is these files loaded? Yeah.
The students, they can ask some questions via they can create a Word file or Notepad, and you can put it into that email ID, or they can put it on the drive, so that you can make a common questions and answers, so it will be compiled. So any students can see that, because the same question will be raised by other students also, so they can see that answers.
Yes, sir. No, so they can keep posting on the drive, and I will answer them as and when required. Okay, so that's for the day. So you can post your comments or any on the single word file. I will. I think we can make a word file here, and I'll try to answer each and every questions. Okay.
Excuse me, sir.
Yeah.
Yeah.
Sir, when I try to open one of these files, sir, .msk files, so it says access violation, sir. Like, it does
Access
not
violation.
get. Yes, sir.
Then I do one thing. This is the Google Drive now.
Yes, sir.
I upload everything on the Google Drive. Are you able to open the Google Drive?
I given the link now. They can use it.
Yes, sir. I am able to open it, sir.
I'm able to open and log in with my details. So that looks good. So I'll just. Yeah, I'm able to remove and classwork.
Sir, it's opening, sir.
Okay, I'm just creating a folder over there and putting all MSK files in the daily classwork designs, so that you can always refer that folder and download stuff from there. Yes, they are getting pushed. Okay.
Yes, sir.
So how you guys will post your answers? Maybe I just make a folder student assignment homework. So you can put your mask files over here. So whenever, and with your name and keep a constant file naming nomenclature. For example, your name is Ramesh. So just put Ramesh underscore inverter one, so that I can always easily I mean, it should not happen like daily wise your name nomenclatures are changing. Otherwise, it will be difficult for me to track everyone's file. Okay. So you can just put up in your daily daily student assignment homework. So you can put your files over there, and we can create a Word file over here where you can ask or post your questions, so that I can read the Word file and write the answers over there. Okay. I think that's enough for the day, and we catch up again tomorrow at the same time. Okay.
Thank you, Mr. Vinay. Thank you, students.
Okay, sir. Bye-bye.
Bye.